Good afternoon. How are you, everyone? Today we'll learn a topic in chemistry. Want to know how to write the chemical formula of compound. But before we do that, please subscribe, like my video, and also share so that we can be learning together with other people. Now, specifically, we are looking on writing, writing chemical formula. How do you write the chemical formula of compounds? How do you write the chemical formula of compounds? Now, when writing the chemical formula of compound, it's very important for you to know the valence numbers of the elements or radicals present. So you have to know the valence numbers. You cannot write the chemical formula of compound without the valence numbers. Apart from the valence numbers, you must know the chemical symbols. Now, when you know these things, it becomes easy for you to write the chemical formula of compound. Now, so how do we find the valence numbers of elements or radicals? Valence numbers of various elements and radicals. We are going to start with metals. The valence numbers of metals. The valence numbers of metals. We are going to start the elements found in group 1, talk about the elements found in group 2, and also those found in group 3, including the transition metals, the D block. What are the valence numbers of these elements? Now, for metals, which are in group 1, 2, and 3, their valence numbers are the electrons which are found in the outermost shell, the electrons which they need to lose for them to be stable. If we give an example of an element in group 1, for example, sodium, has a symbol Na, sodium, atomic number is 11, mass number is 23. Now, if you want to know how many electrons we are in the outermost shell, we use the atomic number, because this number is equal to the number of electrons in this atom. So if we have 11 protons here, we also have 11 electrons. The first shell must always have 2 electrons. The second shell, in this case, it will have 8, then the last shell will have 1 to make it 11. So sodium has 1 electron in the outermost shell. If an element has the electron less than 4, it always needs to lose. So the same number of electrons which it needs to lose for it to be stable is a valence number. So sodium has a valence number of 1. It is also found in group 1. Let us look at an element found in group 2. Let's talk about magnesium. Magnesium, the symbol, it is Mg. Atomic number, it is 12. Mass number is 24. We are using that number again, as usual. We have 2, 8, 2. Magnesium needs to lose 2 electrons in the outermost shell. It needs to lose 2 electrons for it to be stable. So these electrons which it needs to lose is the valence number for magnesium. All the elements in group 2, they have the valence number of 2. All the elements in group 1, they have the valence number of 1. For group 3, talk about aluminium. Atomic number is 13, mass number is 27. We are using the same number again. The first shell has 2, there is 8, then 3 to make it 13 there. So it has less than 4 electrons in the outermost shell, therefore it needs to lose for it to be stable. So these electrons which it needs to lose for it to be stable is a valence number for aluminium. So you can simply say that for group 1, group 2, and group 3, the valence number is equal to the group number. You get that then? So for group 1, they have valence number of 1. Group 2, they have valence number of 2, and group 3, they have valence number of 3. Now, what about the elements found between group 2 and group 3? These are called the D block. So if you have to look at the periodic table, It looks like that. So here we have group 2, here we have group 3, like that. Now we have these elements at the middle there. They are not found in any of these two groups, but they are at the middle of group 2 and group 3. Now what are their valence numbers? These elements are called the D block elements or the transition metals. So what are the valence numbers of transition metals? The valence numbers of transition metals is usually indicated in the bracket because most of these, their valence numbers, they change. They do not have the specific valence number. So most of these elements found in the D block or the transition metals, they do not have the specific valence number. Therefore, each valence number is given in brackets in form of Roman numerals. For example, if they are talking about copper, they can say copper 1, which means that this copper 1 has a valence number of 1. If they are talking about copper 2, it will have copper 2, a valence number on top there. So if you write the name, it will be copper 2. They will indicate the valence number in the brackets there because they do not have a specific valence number. That's why this cannot be placed in group 1, it cannot be placed in group 2 or group 3 because its valence numbers changes. It's not the only example. We also have iron 2, iron 3, iron 4. All these, they are also, transition metals. They do not have a specific valence numbers. They change. So it's clear. If they wanted to write a chemical formula involving the radicals, most of them, they will give you each valence number in brackets. Okay. Now, what about the valence numbers of nonmetals? Valence numbers of nonmetals. Okay. Nonmetals, we're talking about these elements this side here. The elements in group 4, the elements in group 5, group 6, group 7, and the group 8. Now, how do we find the valence number of nonmetals? For example, let's talk about oxygen, which has the atomic number 8, mass number 16. We are using the same number as usual. The first shell has 2. We know that the next shell must have 8, but it would be wrong to put 8 there because the total number of electrons, they should be 8. So instead, how many are remaining to make it 8 here? They're remaining with 6. Now, for the elements, nonmetals specifically, those who have the number of electrons more than 4 in the outermost shell, it means they need to gain the same number of electrons missing, which they need to gain to be stable, is a valence number. So how many electrons are missing here for it to be 8? Since we know that you're supposed to have 8 electrons, 2 electrons are missing. So these 2 electrons which are missing are or is the valence number for oxygen. So oxygen has a valence number of 2. Consider chlorine. Chlorine has the atomic number 17, mass number 35.5. As usual, we have 2, 8, then 7 to make it 17 there. How many electrons are missing for it to be 8? So it is missing only 1. So that 1 electron which is missing for it to be stable is a valence number for chlorine. So chlorine has a valence number of 1. You must know how to find the valence numbers for you to write the chemical formula of compounds. Okay. The other thing we need to know are the radicals. Radicals are also very important in writing chemical formula. They always, in most cases, involve questions with radicals. Now, with radicals, you must know each chemical formula and also each valence number. We have different types of radicals. A radical is a group of atoms which is found in several compounds, but incapable of independent existence. It cannot be found on its own alone, but it is found in most compounds. That's what is called the radicals. Now we have radicals with a valence number of 1. We have radicals with valence number of 2, 3, and also some of them 4, and so on and so forth. So let us start by discussing radicals with a valence number of 1. So the name of the radical here, the chemical formula or symbol, then valency here. We have what is called ammonium. Ammonium has the chemical symbol NH4. The valence number for ammonium is 1. These you just have to know them. They are not found in the periodic table. No, you have to know. If you hear the word ammonium, you must recall its chemical formula and the valence number. We have the hydroxide. We have the hydroxide. Chemical symbol, it is the OH. Valence number, it's 1 as well. We have the nitrate. I'm just talking about few of them, not all of them. So nitrate, the chemical symbol is NO3. The valence number is also 1. These are the common radicals which are found which have the valence number of 1. But we have many other. We have the nitrite, we have the chlorate, and many more. But these are so common, when asking questions, they do bring at least from these 3. Now, what about those with a valence number of 2? What examples can we give those with a valence number of 2? The first one, we have what is called the carbonate. Carbonate has the chemical symbol CO3. It has a valence number of 2. Apart from the carbonate, we also have a sulfate. We also have a sulfate. A sulfate has the chemical symbol SO4. The chemical formula is the same as well, that one. These are the commonly I would give on the one with the valence number of 2. Those are so common which I can give there. The one with the valence number of 3 is a phosphate. Phosphate. Which is the PO4 down there. That's a phosphate. It has a valence number of 3. So these radicals, you have to keep them in your heart so that whenever you hear their names, you have to know the chemical formula. These are not given in most cases. You have to know them. Chemical formula and its valence number. So now, let us try to write some chemical formula of compound. Now, bearing in mind that we have known on how to find the valence numbers and also the valence numbers of radicals and their formulas. So let us write some chemical formulas of compound. We are going to start with the calcium chloride. Write the chemical formula of of the following. The chemical formula of the following: A, calcium chloride. Now, when I've been told to write the chemical formula of a certain compound, calcium chloride for instance, there are 3 steps which you need to follow. First step, you must identify the elements and their correct symbols. You must know the elements present or radical Identify the element or radical. The element or radical with their correct symbols. You must know the element present in this compound, or if there's any radical present there. Second step, you must know their valence numbers. So valence numbers are quite important. Then later on, you write the symbols, the valence numbers on top. Write the valence numbers on top of the symbol. So write valences on top right of each symbol. Then at the end, you are going to exchange the valences. Exchange the valences. Those are the steps we need to follow. Okay, let's consider this one here. Calcium chloride. What are the elements present in calcium chloride? We have calcium element and chlorine. The chemical symbol for calcium is Ca. The chemical symbol for chlorine is Cl. What is the valence number of calcium? Calcium has the atomic number 20, and it is found in group 2, so it's quite easy. Those in group 2, they have the valence number of 2. So calcium has a valence number of 2. Now you need to write its valence number on 2 right there. We go to chlorine. What is the valence number of chlorine? Remember, I defined it somewhere there, which is 1. Chlorine has a valence number of 1. Now you need to exchange the valences. This one comes here, this 2 goes there. So this is calcium. K1, we're going to indicate it like that in the first place. Then we have the Cl chlorine. Then this 2 goes there. When writing these valences, you have to write them, in this case, when writing the chemical formula, you write them on bottom right of each symbol. But when it is 1, you are not supposed to show the 1. Just write it calcium chloride. So that is the chemical formula for calcium chloride. What is important is knowing the valence numbers. Okay, let's consider the other example. Sodium carbonate. Sodium carbonate, remember carbonate is a radical. Element is sodium, the symbol it is Na. A radical is a carbonate, the symbol is CO3. What is the valence number of sodium? Sodium is found in group 1, therefore it has a valence number of 1. I already explained in the beginning. Then a carbonate is a radical. I said you have to know each chemical formula and the valence number. N has a valence number of 2. We exchange the valences. The 2 goes there. That is sodium 2. Remember, when it is a 1, we said you are not supposed to show it. Carbonate. That is sodium carbonate. Now, there are times, if we give the other example, magnesium hydroxide, there's something I want to explain there. Magnesium hydroxide. Okay, I got the wrong spelling there. Magnesium hydroxide, the element present is magnesium. The other thing present there is a radical, which is OH hydroxide. What is the valence number of magnesium? It is found in group 2. Therefore, valence number is 2. Hydroxide it has a valence number of 1. From that table we drew there. You exchange the valences, so the 2 goes there. 1 comes to magnesium, so I'm just going to write magnesium. Don't show the 1. 2 goes that side, but where are you going to write the 2? This 2 is multiplying with these 2 atoms. So if you want it can be written as 2 oxygen and also hydrogen 2. You see that, eh? But because 2 is a common factor, it's not supposed to be written like that. No. So the correct way of writing this formula is you put these 2 atoms in brackets OH, then the 2 goes outside like that. This is magnesium hydroxide. Okay, I believe you have seen that these are quite easy things. What is important, knowing the symbols and the valence numbers. And therefore we come to the end of the lesson for today. Please don't forget to subscribe, like the video and share so that more people can come on board to learn together in the world of science. Thank you. Have a blessed day.